Hey guys, this is an important topic again about independence, statistical independence, and I want you to focus on the concept independence here in this video. Okay, so the definition of independence, bağımsızlık, is like if two events are independent, if knowing one of them that occurred does not change the probability of the other one. Okay, if I know that something has occurred, does the probability of knowing this affects the other one? If they affect each other, they are not independent. If they do not change each other, they do not affect each other. If there is no influence with each other, then we can call them they are independent. Okay. For example, I'm flipping a coin, I'm rolling a die. Are they dependent each other? Do they depend on each other? If this comes, let's say, when I roll a die, obtaining a 3, and when I flip a coin, obtaining a heads, these are totally independent events, right? Or flipping a coin 2 times, like obtaining a heads in the first one and obtaining a heads in the second one is totally independent from each other. Let me give you a couple of examples for you to understand this topic of independence. For example, if I toss a coin twice and I am, if I say that would obtaining a heads in the first toss, would it affect obtaining another head in the second toss or obtaining a tail in the second toss? No, right? So this doesn't, obtaining a heads in the first one does not affect or does not have any influence on obtaining any kind of solution in the second toss. Then they are like independent of one another. Okay. So the first one is very easy. Okay, how can I prove that? For example, there might be such questions. Can prove that A and B are independent from each other? How can I prove this? So there are a couple of things, like a couple of formulations that we can work on. If you remember, like A given B, conditional probability, is like if there is an intersection, the probability of intersection divided by PB is going to be is the conditional probability, right? If if the uh, if the occurrence of B does not affect occurrence of A, then it will be equal to PA, right? So knowing B does not affect the probability of A events. So how can I prove the independence of two events? Either probability of A given B is equal to A. We should know this. We should, if this is the case, then I can immediately say that A and B are independent from each other. Another thing is, coming from here, I can write probability of A intersection B is equal to this times this, right? PA times PB. So if two events are independent from each other, I can easily say that their intersection, probability of intersection, will be the multiplication of probability of each one. Okay, so the definition is that occurrence of one does not change the probability of the other one, is the main definition of independence. So how do I prove, or how do I determine that A and B are independent from each other? I may either use this formulation, PA given B is equal to PB, or probability of A intersection B will be equal to probability of A times probability of B. Okay, so let us work on a couple of examples. We can still say, let us toss a coin twice, and the first one is like heads on first toss, and the second event is going to be heads on second toss. Okay, the question is, are H1 and H2 independent from each other? So how many options do I have arkadaşlar? Heads, 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 tail, tail, heads, and tail, tail, right? These are 4 options that I may have, that I may obtain from a fair coin that is flipped 2 times. So what is like the intersection of P, H1 and H2? So that means heads on first toss and heads on second toss. So that means it should happen this at the same time. Okay, what is the probability of this? It is 1/4. 1 out of 4 options. So what is PH1 arkadaşlar? PH1 heads on first toss 1/2. Heads on second toss 1, 2, again 1/2, or 2/4 and 2/4, right? So what is this 1/2? Again, what is this 1/2? So probability of H1 times probability of H2 will be equal to 1/4. So if this 1/4 is equal to this 1/4, then we can say, yes, they are independent. Okay, so I should first focus on the intersection of these 2 events. I will find the probability of the intersection first. Then I will find the probability of separate cases, separate events, probability of H1 and probability of H2. Then I will multiply them and compare with the probability of the intersection. Okay, that's how we will follow. If these 2 are equal, then we will say they are independent. Let's move on to another example, which will show very important aspects of this in statistical independence. So toss a fair coin 3 times this time, okay? What are the possible outcomes arkadaşlar? Head, 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 tail, head, tail, heads, and then head, tail, tail, and then tail, heads, heads, tail, heads, tail, tail, sorry, tail, tail, heads, and then tail, tail, tail. Okay, there are 2 to the power 3 options, possible outcomes, 8 outcomes, and this is the event 1, heads on first toss. Okay, this is event 1, and event 2 is A, 2 heads total. So I have 2 heads here, I have 2 heads here, and I have 2 heads here, and I have I don't have any other 2 heads case. So these are the A event is gonna be like this, this, and this. Okay. So what is the intersection arkadaşlar? Probability of A intersection H1, probability of A intersection H1, 3 possible cases, but the intersection, this is like 3 possible cases that 2 heads are obtained. But when I know that heads on first toss, so I should look at this one right now, and these are going to be my my intersection. Okay, so 2/8 will be my probability of obtaining heads on first toss and 2 heads total. Okay, so out of 8 possible outcomes, 2 of them will have heads on first toss and 2 heads together. Okay, how about PA? What is PA? We said it is 3/8, 3 possible outcomes out of 8 outcomes, and PH1 will be 1/2, right? So half of the possible outcomes are going to have first toss as heads. So what is the multiplication of these 2? It is 3/16. What is this? 1/4. So these 2 are not equal, so they are not independent from each other. Okay, so that means knowing H1 will affect the probability of A. Okay, so let us move on to the final part. Let me remind you of this. Let me give you a summary of what's going on. What did I do, arkadaşlar? Either I said A given H1 is equal to PA, okay, or I should say PA intersection H1 will be equal to PA times PH1. Okay, you may do both in these kind of examples. I have usually used this one, but in the last question here, we may also use this in our solutions. PA given H1 will be PA given H1 will be 1/2. Why? Because I know that the first toss, there are 4 such cases, and 2 of them are 2 heads total. So I will have 2/4. So what is PA? PA is equal to 3/8. And then we will check 1/2 is not equal to 3/8, so they are not independent. So here, I wanted you to realize I might have 2 different pathways to prove the independence of 2 events. Okay, that's all for this video.